Over 99% of all the creatures that have ever walked, swum or slithered across our planet are gone. Some, like Tyrannosaurus rex or Triceratops, are instantly recognisable, fearsome, legendary, etched into our imagination. But then there are the really weird ones. Animals with heads shaped like boomerangs, eyes sticking out on long stalks, limbs that twist in ways that make you do a double take, or bodies so armoured they look like little walking fortresses. They look less like creatures of this earth and more like something ripped from an alien world. These are the beings that defy expectation, the ones that make paleontologists stop in awe, questioning how evolution could conjure something so extraordinary, so bizarre, and yet so real. The Tully Monster, or Tully Monstrum gregarium, is one of the strangest creatures ever to swim the Earth's oceans. This soft-bodied marine animal lived about 310 million years ago in shallow tropical estuaries covering what is now Illinois. Despite being common in the Mason Creek fossil beds, its bizarre anatomy has baffled scientists for decades, making its classification one of paleontology's longest-running mysteries. Tully Monstrum had a mostly cigar-shaped body with a triangular tail fin, two stalked eyes, and a long, flexible proboscis ending in a jaw lined with small, sharp teeth. Fossils suggest it was a free-swimming carnivore, hunting small prey in the open water rather than sticking to the seafloor. Adults could grow up to 35 centimeters or 14 inches, while juveniles were around 8 centimeters or 3.1 inches long. Some evidence indicates it had a pair of vertical ventral fins near the tail, which probably helped it maneuver through its watery environment. Its proboscis may have actively probed mud for small creatures or edible detritus, making it an effective predator in a complex ecosystem of estuaries, rivers, and marine environments. Part of what makes Tully Monstrum so remarkable is its lack of hard parts. No bones, shell, or chitin, leaving only impressions of its soft tissue. Fossils reveal repeated internal segments, possible gills, and a structure that might have served as a rudimentary spinal cord. Its stalked eyes appear to have been camera-type organs, with melanosomes suggesting well-developed vision. In 1955, amateur fossil hunter Francis Tully found the first specimen and brought it to the Field Museum, leaving paleontologists completely stumped. Over the years, it has been compared to worms, mollusks, arthropods, conodonts, and vertebrates. Some studies suggest it was a basal vertebrate, others a non-vertebrate chordate, or even a protostome. Its unusual features have drawn comparisons to Cambrian fossils like Opperbonia and Nectocaris, yet no consensus has been reached. Its preservation is just as extraordinary. Rapid burial in silty sediments and the formation of iron-rich siderite nodules locked in delicate soft tissues, giving paleontologists a rare glimpse of one of the most alien-looking animals in the fossil record. The proboscis itself is rarely preserved in full, appearing complete in only about 3% of specimens. Yet even partial impressions reveal a creature unlike anything alive today. Tully Monstrum isn't just a fossil, it's a reminder that evolution can produce forms so strange they defy categories, and that even after 310 million years, some mysteries of the ancient seas remain unsolved. Hallucigenia is hands down one of the weirdest creatures to ever creep through the oceans. It lived around 500 million years ago, smack in the middle of the Cambrian era, right after the Cambrian explosion, when life on Earth went from simple blobs to full-on wild diversity. Back then, almost everything lived in the oceans. Land was still mostly barren, and the first plants were just getting started. The first fossils were discovered in 1911 in Canada's Burgess Shale by Charles Doolittle Walcott. He thought they were segmented worms, annelids, and called them Canadia. Turns out he was way off. The creature's body is long, thin and worm-like, only a few centimetres wide, and usually about 1 to 3 centimetres or 0.39 to 1.2 inches tall in fossils, with most individuals ranging 1 to 5 centimetres or 0.4 to 2 inches long, though some could stretch longer. Its back is lined with long, sharp spines, which we now know were defensive, like a natural armour. Underneath are stubby, flexible legs, each tipped with tiny claws, used for walking along the sea floor. In 1977, Simon Conway Morris renamed it Hallucigenia because of its dreamlike, bizarre appearance. He originally thought it walked on its spikes and used the tentacle-like appendages on its back for grabbing food. But decades later, Lars Ramsgaard and Hu Shongwang examined fossils from China and realised it had been reconstructed upside down the whole time. Those spines? Definitely for defence. The appendages? Actual legs with claws for walking and gripping the substrate. Hallucigenia's head was another mystery. Fossils often show a dark blob at one end, which early researchers assumed was the head. Ramsgaard suspected otherwise. Maybe it was just guts squished out after death. In the 2000s, it was confirmed that the real head had two simple eyes, a small mouth, and even needle-like teeth in the throat. Functionally, Hallucigenia was a crawler and a scavenger. It probably walked along the ocean floor picking up small prey or detritus with its flexible legs. Its spines kept predators at bay, and its soft, elongated body allowed it to wiggle through tight spaces. It's classified as a lobopodian, part of the same group as modern velvet worms. So, despite looking like a spiky alien, it actually has living relatives. Peering back 500 million years into the Cambrian oceans turns up some of the weirdest creatures you'll ever see, and the Opabinids are right at the top of that list. Most people know Opabinia regalis, first described in 1912 with its 5-stalked eyes, backwards facing mouth and a long hollow proboscis it probably used to grab small prey off the seafloor. This thing was bizarre, no two ways about it, and for decades it seemed like a one-of-a-kind oddball. Now, meet its distant American cousin, Euterora camosa. Originally described as a radiodont back in 2008, this spiky, segmented, soft-bodied arthropod has been reclassified as an Opabinid after some serious detective work by paleontologists like Joe Wolfe and Stephen Pates. Euterora lived a few million years later than Opabinia and was discovered in Utah's Wheeler Formation, rather than the Canadian sites where Opabinia fossils are found. In life, Opabinia and Euterora were fairly small, around 7 to 10 centimeters long, or about 2.8 to 4 inches, and roughly 1 centimeter wide, around 0.4 inches. Their bodies were soft, segmented and flexible, with lobed flaps along the sides for swimming. The proboscis acted like a grabber. Think of it as a long, tubular claw, perfect for picking up tiny worms and other soft-bodied prey. Their 5 eyes on stalks probably gave these animals a near 360-degree view of the world, helping them spot both predators and dinner. The reclassification of Euterora came after comparing its morphology to 43 other fossil species and 11 living arthropods. While it shares some features with radiodonts, think Anomalocaris, new data shows that Opabinids form a separate branch on the arthropod family tree. Features like intersegmental furrows along the back and paired serrated spines on the tail help tip the scales. Phylogenetic analyses now show that Euterora fits with Opabinia in about 68% of the trees, versus less than 0.05% with radiodonts. Functionally, these guys were bottom dwellers and slow swimmers, using their flexible bodies and flaps to navigate seafloor currents while the proboscis scooped up the food. Opabinids may have been small, but they were Cambrian weirdness in its purest form, and now, thanks to Euterora camosa, we know Opabinia isn't alone. These strange, 5-eyed grabbers were part of a bigger evolutionary story, helping us trace the early roots of modern arthropods. Diplocaulus immediately grabs your attention with that insane boomerang-shaped skull. This critter was part of the Lepospondyls, a crew that lived from the late Carboniferous to the late Permian, about 300 to 250 million years ago. Most Lepospondyls were tiny little squirmers, but Diplocaulus went big, stretching up to 1 meter or 3.3 feet from snout to tail. Fossils hint at a long, whip-like tail, which it probably used to snake through the water with smooth, eel-like moves. Its stocky, salamanderish body kept it stable, while those wild horns balanced the heavy front end evolution was flexing hard here. Now, those boomerang horns? Made mostly of tabular bones, with squamosal and postparietal edges framing the head, they widened the skull and it turned into a built-in water slicer. Paleontologists have thrown around tons of ideas. Maybe they protected the gills. Maybe they acted as a counterweight. The real winner? Hydrofoils. Tests show those horns generated lift, letting Diplocaulus rise through rivers or attack prey without losing steam. Open its mouth? Still totally efficient. Tilt the head just a bit, and it was basically surfing the water like a champ. Diplocaulus wasn't rolling solo either. Fossils show juveniles hanging in burrows together, sometimes chilling with other amphibians. But it was a rough world out there. Predators like Dimetrodon weren't playing around. Bites to the head killed some of the young ones. Even with that crazy skull and slick moves, life wasn't guaranteed. It's all eyes. This Jurassic arthropod, scientifically known as Dolichoris ingens, is famous for having enormous compound eyes, each packed with something like 18,000 ommatidia. Those are the individual pixels of a compound eye. These eyes were huge, roughly a quarter of Dolichoris' body length, and that gives you an idea. This creature saw a lot. Scientists working on fossils from the Lavaux-Siron-Lagastetta in France were able to reconstruct its eye structure in detail, down to the receptor cells. Thanks to that, they concluded Dolichoris probably had panoramic, high-resolution vision, ideal for detecting movement. Size-wise, Dolichoris is modest, but not tiny. Estimates put it at 5 to 20 centimeters long, about 2 to 8 inches. Despite its relatively small size, its body had some serious predatory gear. It had a crab-like carapace, 3 pairs of clawed, segmented legs, plus about 8 pairs of short swimming limbs. The swimming legs weren't built for speed though. Instead, Dolichoris probably relied on ambush tactics, lurking in the shadows, waiting for prey to come into view. Under the hood, its anatomy supports this predator lifestyle. Inside, it had gills, 8 pairs according to reconstructions, and a segmented abdomen with short pleopods, little appendages, that likely helped it ventilate. That visual power Dolichoris possessed likely let it detect motion from a distance, which is super useful if you're lying in wait and want to strike quickly. Researchers also found cryptic clues in its gut contents, undigested remains of mobile prey, confirming that Dolichoris was indeed a visual predator. As for where it fits on the tree of life, Dolichoris belongs to a weird, extinct group called Thylakocephala. These animals had a very unusual body plan, and scientists are still debating exactly how they relate to modern crustaceans. Ubirajara, or Lord of the Spear, is one of those dinosaurs that instantly grabs attention, even if its story is as wild as its name. This little compsognathid theropod lived in what's now Brazil during the early Cretaceous, around 115 million years ago, and the individual we know about would have been roughly 1 meter long, or 3.3 feet. That's a small, nimble predator, but what makes it stand out isn't its size. It's the crazy plumage and ribbon-like structures it sported. The fossil we have comes from the Crato Formation. It's a partial skeleton of a juvenile, possibly male, preserved on a slab and counter-slab. Scientists recovered 9 neck vertebrae, 13 back vertebrae, 2 sacral vertebrae, the shoulder girdle, a bunch of ribs, and almost the entire left arm, along with incredible soft tissue details, feathers, skin, granulate torso structures, and even keratin sheaths on the hand claws. That kind of preservation is insane for a non-avian dinosaur. Ubirajara had proto-feathers all along its neck and back, forming what looked like a short mane, plus a pair of long, ribbon-like shoulder filaments. These weren't for flying or anything like that, they were display features, probably used to impress mates or intimidate rivals. From a classification standpoint, Ubirajara was slotted into the Compsognathidae family, supposedly closely related to Sinosauropteryx and Compsognathus, but the data supporting this placement were never fully published, so scientists can't properly test or replicate it yet. Its evolutionary position is still kind of up in the air. Even with all the controversy, one thing is clear: Ubirajara was a flashy, small predator with a mane and shoulder ribbons built for show, and it gives us a rare glimpse of the insane diversity of feathered dinosaurs in Gondwana. Teratopeton, whose name literally means wonderful creepy thing, is one of those Triassic reptiles that makes you go, wait, what? Found in the late Triassic Wolffield Formation of Nova Scotia and described in 2003, this animal was no ordinary archosauromorph. Its skull alone sets it apart. Long, toothless at the snout tip, with massive nostril openings and bony projections above the eyes that gave it a seriously distinctive look. Early on, scientists thought it was unique enough to deserve its own family, Teratopetidae, but newer studies generally slot it into the Trilophosauridae, making it a close cousin of the Trilophosaurus. The head is where Teratopeton's quirks really shine. Teeth don't line the front of the jaws, instead they're tucked farther back, small, sharp and closely spaced, with an upper jaw row set in from the edge. Bonus: there's even a second tooth row on the palate that meshes perfectly with the lower teeth. Think of it like a precision bite, where every cusp fits neatly into its opposite indentation. And here's the jaw dropper. Teratopeton had a Eurapsid-style skull, meaning it had a single hole at the back of the skull, the supratemporal fenestra, rather than the typical diapsid two-hole setup. Yet it's still technically a diapsid descendant, evolution throwing a curveball basically. Its nostrils? Huge. The narial fenestra stretches from the right in front of the eyes to the toothless snout tip, about 1.5 times the length of the eye socket. This giant opening gives the skull a weird, almost alien vibe, and initially confused researchers who thought it might be an antorbital fenestra. Alright, imagine Teratopeton is like a super weird lizard from a long time ago. Its neck bones are kinda like a stack of building blocks, some with little spikes sticking up, like a dinosaur mohawk. The ribs in its neck are glued to the bones, so it's super sturdy there. Its back, hip and tail bones have long sideways bits that look like little shelves, probably to help muscles attach so it can move well. Teratopeton is known mostly from a single partial skeleton found on a sea cliff at Burnt Coat Head. The surrounding Wolffield Formation, part of the Newark supergroup, preserves a late Carnian ecosystem with temnospondyls, proclophonids and traversodont cynodonts, and this weird little archosauromorph is a perfect example of Triassic experimentation. A long-snouted, tooth-shifted, single-holed skull reptile that fits snugly between Trilophosaurus and more derived rhynchosaurs. Gerathorax, meaning wicker chest, was a seriously strange amphibian from the Triassic, stretching from Greenland to Germany, Poland, Sweden and maybe even Thailand. About 1 meter long or 3.3 feet, it had a pancake flat body, perfect for chilling under mud or sand at the bottom of rivers and lakes. Its big, upward-facing eyes were like built-in periscopes, scanning the water above for unsuspecting prey. One of the wildest things about Gerathorax? It kept its gills for life. Scientists originally thought it had feathery external gills, like an axolotl, but later research showed it had internal gills, more like a fish. That meant its breathing system was protected by skin folds, no risk of damage while lurking on riverbeds or hiding from predators. When it came to feeding, Gerathorax had a trick straight out of nature's playbook. Instead of opening its jaw like most animals, it lifted its head to catch prey, a motion compared to a toilet seat flipping up. Strong muscles and its robust gill arches created a suction effect, pulling in fish or crustaceans. Tiny denticles on the gill's arches made sure nothing escaped once inside. Unlike modern fish, its skull bones were fused, so all this suction power came without flexing the bones, efficient and deadly. Gerathorax is also a master of stasis. Its fossils show almost no changes over 35 million years, making it an extreme example of evolutionary consistency. Why? It could survive in a wide range of aquatic environments, from freshwater rivers to brackish lakes. As long as there was water, it was good. Its skull was distinctive too, flat, wide with angular side protrusions. Reminds you a bit of Diplodocus, but less exaggerated. The shape probably helped it stay hidden and move through water efficiently, all while keeping an eye out for dinner. Psittacosaurus, or parrot lizard, was a small bipedal ceratopsian dinosaur that roamed Asia during the early Cretaceous, roughly 125 to 105 million years ago. It's famous for being the most species-rich non-avian dinosaur genus, with up to 13 known species found across China, Mongolia, Russia and Thailand. Adult Psittacosaurus were obligate bipeds with a high, short skull and a strong, parrot-like beak, perfectly adapted for cropping tough plant material. Some individuals even had long, filament-like structures on their tails, similar to those seen in Tianyalong. Psittacosaurus ranged from about 1 to 2 meters, or 3 to 6.5 feet long, with weights up to 20 kg, or 44 pounds in larger species. As one of the earliest ceratopsians, Psittacosaurus sits closer to Triceratops than to more primitive forms like Yinlong. Studies of growth rings and bone histology suggest rapid growth in the first few years, reaching sexual maturity around 10 years of age. Juveniles may have been quadrupedal, switching to a bipedal stance as they matured, reflecting an evolutionary path from four-legged ancestors. Psittacosaurus had a unique skull design, extremely tall, short, and nearly round in some species. Its jaws bore self-sharpening teeth and a keratin-covered beak, ideal for shearing vegetation, seeds, and nuts. Unlike later ceratopsians, it lacked a full frill or prominent horns, though some species, like Psittacosaurus sibiricus, had small cranial projections. Its forelimbs were short and could grasp or scratch, but they weren't used for locomotion. Hind limbs were powerful, supporting its fully bipedal lifestyle. Some well-preserved specimens, particularly from the Yishuan Formation in China, reveal scales and bristle-like structures along the tail. These bristles were likely keratinous and arranged in tight clusters, somewhat like quills of modern birds, but not true feathers. Pigment studies indicate countershading, with patterns on limbs, shoulders and face, likely for camouflage and display. Psittacosaurus also had excellent vision and smell, hinting at complex behaviour. Its brain was proportionally advanced for a ceratopsian, suggesting intelligence comparable to that of Tyrannosaurus, capable of nest building and intricate social behaviours. Fossilised groups show mixed age herds, and juveniles may have stayed together for protection or cooperative behaviours. Predation on young Psittacosaurus, including by mammals like Rhipinomymus, may explain their reproductive strategy of producing numerous offspring. Nigersaurus was a bizarre small sauropod that lived in what is now Niger during the Middle Cretaceous, around 115 to 105 million years ago. First discovered in the Elraz Formation, its fossils were described in 1976, but it wasn't officially named Nigersaurus tequati until 1999, honouring paleontologist Philip Tequay. Unlike most massive sauropods, Nigersaurus was relatively small, about 9 to 14 metres or 30 to 46 feet long, weighed roughly 2 to 4 tonnes, similar to a modern elephant, and had a short neck with only 13 cervical vertebrae. Its skull was extraordinarily specialised for feeding. Nigersaurus had a wide, almost square muzzle filled with over 500 teeth, all positioned at the very front of its jaws. These teeth were replaced rapidly, every 14 days, and the jaws likely had a keratinous sheath to aid in cropping low-lying vegetation. Uniquely, both upper and lower tooth rows were rotated outward, giving Nigersaurus a truly ground-level vacuum cleaner mouth, perfect for non-selectively gathering ferns, horsetails, and early flowering plants within a metre of the ground. Its bite, however, was surprisingly weak for a sauropod, and chewing was minimal, relying instead on rapid tooth replacement to handle its herbaceous diet. Nigersaurus belonged to Rabachosauridae family of diplodocoid sauropods. Its skeleton was highly pneumatized, filled with air spaces connected to air sacs, which reduced weight, conserved energy, and may have helped it cope with the hot, tropical environment. Its robust limbs supported a quadrupedal stance, with a small head, thick hind legs, and a long, tapering tail. Unlike other long-necked diplodocus, its short neck meant it grazed close to the ground rather than reaching high into the canopy. Biomechanical studies suggest that Nigersaurus likely held its head angled downward, almost at ground level, for efficient feeding, although some researchers argue it may have occasionally raised its head horizontally. Its unusual anatomy, rapid tooth replacement, and specialised feeding habits make Nigersaurus one of the strangest and most fascinating sauropods. A true ground-level grazer, unlike any other dinosaur. Fossils of this dinosaur remain common in its native Niger, painting a vivid picture of a unique herbivore, thriving in the lush riparian habitats of the Middle Cretaceous.